Hello everyone, welcome to the third lab section for Arena simulation software. In this section, we will talk about the two models. The first model is the cell electronic assembly and test system model. Then we will enhance the model by enriching the scheduling, failure, and state results. Let's move to the first model, the electronic assembly and test system. We will discuss how to develop a modeling approach, introduce several new arena concepts, build the model, and show you how to run it and view the results. This system represents the final operations of the production of two different sealed electronic units, which is shown in this figure. The arriving parts are cast metal cases that have already been machined to accept the electronic parts. The first units, called Part A, are produced in an adjacent department outside the bounds of this model, with inter-arrival times to our model being exponentially distributed with a mean of 5 minutes. Upon arrival, they are transferred to Part A prep area, where the mating phases of the cases are machined to ensure good seal, and the part is then deburred and cleaned. The process time for the combined operation at the Part A prep area follows a triangular distribution. The part is then transferred to the sealer. The second units, called Part B, are produced in a different building, also outside the model's bounds. They are held until a batch of 4 units is available. The batch is then sent to the final production area where we are modeling. The time between the arrivals of successive batches of Part B to our model is exponentially with a mean of 30 minutes. Upon arrival at the Part B prep area, the batch is separated into the 4 individual units, where are processed individually from here on, and the individual parts persist to the Part B prep area. The processing at the Part B prep area has the same 3 steps as at the Part A prep area, except that the processing time for the combined operation follows a different triangular distribution. The parts then sent to the sealer. At the sealer operation, the electronic components are inserted, and the case is assembled and sealed, and the sealed unit is tested. The total process time for these operations depends on the part type, triangular for Part A and Weibull for Part B. 91% of parts pass the inspection and are transferred immediately to the shipping department. Whether a part passes is independent of whether any other parts pass. The remaining parts are transferred into the rework area, where they are disassembled, repaired, cleaned, assembled, and retested. 80% of parts processed at the network area are salvaged and transferred to the shipping department as reworked parts, and the rest are transferred to the scrap area. The time to rework a part follows an exponential distribution with a mean of 55 minutes and is independent of part type and the ultimate disposal. We can simplify this step into the following components: part arrival, prep areas, sealer operation, rework, part dispatcher, and the parts animation. We will run the simulation for 1920 minutes. Let's open the Arena simulation software. Because we have two different kinds of arriving entities to our model, each with its own timing pattern. We will use two separate create modules to generate the arriving part. So let's drag the create module into the model window. Do it again. Then open the create1 module, change the name to the part A arrive. And change the entity name to part A and set the value at 5 and change the unit to the minutes. Then keep the entities per arrival as 1. Click OK. We do the same things for the create2 module. Open it first and then change the name to the part B, arrives. Then change the entity name to the part B. Then set the value as 630 and change the unit as minutes. Because the part B entities arrive in batches of 4, thus the entity will cause each arrival to consist of 4 separate entities rather than 1. So we change this 1 to 4 and then click OK. Then we will change this entity's appearance. To change the appearance, we go to the data definition toolbar, then click entity. Now we use the green ball to represent the part A and use the blue ball to represent the part B. Let's move back to the discrete processing toolbar. I will introduce a new module which is named Assign module. This module is used for assigning new values to variables, entity attributes, entity types, entity pictures, or other system variables. Multiple assignments can be made with a single assign module. We have different processing times by part type at the sealer operation. So we will use two assign modules to define an attribute called the sealer time that will be assigned the appropriate sealer processing time after the parts are generated by the create module. So we drag the assign module into the model window and do it again. We will delete this connection and open the assign module. And firstly, we change the name to the assign part A sealer and the arrive time. Then add the sealer time. So we first change a tab to the attribute, then change the name to the sealer time. And we right-click this bar and choose the build expression and go to the randomly distribution and find the triangular distribution and set the value as 1, 3, 4. Then click OK. We will also define an attribute arrival time, which is used to record the arrival time of the entity. So we add the new attribute and we name as the arrival time. And right-click this bar and choose the build expression, and go to the date and time function, choose the current simulation time, and click OK. Here. Let's do the same things to the another assign module. Open this module, and then change the name to the assign part B sealer and arrival time. And then add the sealer time. We first change the type's attribute, then type the name sealer time, and find the variable distribution here, and the number is 2.5, and this one is 5.3. Click OK. Then add the another attribute arrival time. Find the current simulation time and click OK. Now we have completed 2 part arrival modules and the assignment of the sealer times. We can now move to the 2 prep areas that can be modeled by using 2 process modules. So let's drag 2 process modules into the model window. And delay those connections. Let's open the process 1 and change the name to the prep A process. And as we do before, so we choose this delete release function, and then as the resource, we can change the resource name to the prep A. And keep it as 1, and then click OK. For the delete type, it is triangular, and for the units, we change it to the minutes. And then the minimal value is 1, the most one is 4, and for the maximum, it's 8. Then click OK. And we can tune this one to here, and add the connection. We do the same thing for the process 2. We change the name to the prep B process. and you choose sys delay release function, and then add a resource. We change the name to the prep B, and click OK. The delay type is triangular, the unit is minutes, the minimum is 3, and the average is 5, and the maximum is 10. And then click OK. Add the connection again. Tune this position. Here. The next step is to enter data for the sealer operation. So let's drag the process module into the model window. Then double-click the process 3 to open this dialog. We first change the name to the sealer process. And choose to use this CD release function, and then add a resource. We change the resource name to the sealer, and click OK. And for the delay tab, we choose expression, and the unit we change to minutes. And we type the expression function as the sealer time. Note that in the upstream assign modules, we define the attribute sealer time when the arriving parts were created. When an entity gains control of OCs, the results it will undergo a process delay equal to the value constrained in its sealer time attribute. It allows for different distribution for parts A and parts B. Then click OK. So next we will add the connection. Now I will introduce another different kinds of module, which is in the decision toolbar named decide module. Let's drag this module into the model window. Then open the decide one, and first change the name to the field sealer inspection. And keep it as two-way by chance, and change this value to 9, which means that 9% of the entity will be treated as the field items. Then click OK. Next step, we will create the connection. According to the system description, we know that if the parts can pass the inspection, which will be sent to the shipping, or it will be sent to the rework. So let's use the one more process module to represent the rework process. Go to the discrete processing toolbar, then drag the process module into the model window. Let's open the process module. We first change the module name to the rework process. And then change the action tab as a sys delay release. And then as a resource, change the resource name to the rework. And keep it as 1 and click OK. For the delay tab, we choose expression, and the units is minutes. For the expression function, we go to this one and change the mean value to the 45. Then click OK. Next, we will create a connection and tune the Q position. Let's make one more decide module to separate the sandwiched and crab parts following rework. So let's go to decision toolbar, then drag the decide module into here and double click it and change the name to the field rework inspection. And change 50 to 20 and click OK. And then add the connection. I will introduce another kind of module, which is in the input-output toolbar named record module. This module can be used to record the output. So let's drag the record module here. Do it again and again. Then let's delete those connections. Let's open the record one module and first change name to the record script parts. Then we click at the button. So for the tab, it's the time interval and choose the attribute name to the arrive time. And for the tally name, change it to the record script parts. Then click OK. Let's do the same things for the record 2 module. Change it to the record salvage part. And add the time interval, attribute choose it to the every time to the record salvaged parts. And do the same thing for the third record module, record shaped parts. Click OK. Yeah. At last, add the connection. At last, let's drag 3 dispose modules from the discrete processing toolbar here. Let's change its name first to scrap. And then change the second to the salvage. Choose the third one to the shipped. And create the connection. Now this model is ready. Let's set some running conditions to run this simulation. So let's first go to the run toolbar, then click setup and go to the replication parameters. Change the lines to 32 and change the base time units to minutes. Then go back to the project parameters, change the project title to the electronic assembly and test. And for here, click processes and click OK. Okay, let's run this simulation. For now, let's click yes to see the report. This is how report looks like. Let's go to the discrete time sheet. In this sheet, we can get the total time, transfer time, waiting time, and all the other time. Let's move to another model. In this model, we will enhance the previous model by enriching the scheduling, failure, and states of resources, and give you alternative methods for studying the results. In the previous model, we just look at the operation for the first shift, but this system actually operates 2 shifts a day. And on the second shift, there are 2 operators assigned to the rework operation. This could explain our earlier observation when we thought the rework operation might not have enough capacity. The previous model has no failure problem at the serial operation. Periodically, the server machine breaks down. Let's assume that the mean uptime was found to be 120 minutes and that the distribution of the uptime is exponential. The time to repair also follows an exponential distribution with a mean of 4 minutes. In addition, the production manager indicates that she was considering purchasing special racks to store the waiting parts in the rework area. These racks could hold 10 assemblies each, and she would like to know how many racks to buy. So now we need to model the changes in shifts because we have only 1 operator in the first shift and 2 in the second shift. For the rework process, we will add this to our model by introducing a resource schedule for the rework resource, which will automatically change the number of rework resources throughout the run by adjusting the resource capacity. We will also increase the run lines so that we simulate more than just 2 days of a 2-shift operation. We will model the server failures using a resource failure, which allows us to change the available capacity of resource, but has additional features specifically designed for representing equipment failures. Finally, we will use the frequencies statistic to obtain the type of information we need to determine the number of racks that should be purchased. Let's go back to the previous model. At first, we go to the running conditions and then change the replication length from 32 hours change to the 10 days. And then change the hours per day from 24 to 16. Then click OK. To change the resource schedule, we have to go to the data definition toolbar, then find the resource module, click it, and then find the rework resource. In the previous model, it is a fixed capacity. So now we change it to the based on schedule. Here you can see there has two more columns. One is a schedule name, another is schedule row. We first change the schedule name to the rework schedule. There exist three options for the schedule rule. The ignore option, which means that it will decrease the resource capacity, ignoring the fact that the resource is currently allocated to an entity, but work on the in-serve entities continues unabated. The wait option will wait until the in-process entities release their units of the resource before starting the actual capacity decrease. The preempt option attempts to preempt the last unit of the resource seized by taking it away from the controlling entity. In this system, we will choose to use the ignore option. Let's go back to the data definition toolbar, and just behind the resource module, it has a schedule module. Click it, which will show the schedule which we just created, rework schedule. Then we will let the unit as hours and for the duration. If we click here, we can see dialog. So we double click here to add a new row because we have two shifts. So there exist two rows. For the first shift, it has one operator, and for one shift, it has 8 hours. For the second shift, it has two operators, and the duration is 8 hours. So now you can see that the duration has two rows. Let's move to the cellular failure. How can we do that? Let's first go back to the resource module, then find the cellular. Here in the failures cells, it shows that it has 0 rows, so we double click it. You will be able to see this dialog. Then double click here to add a new row. We can first change the name to the cellular failure. And changes the failure rule to the wait. When we finish it, we can close this dialog. Now you will be able to see the failure in the failure module. Click it, and we will change the tab to the time. And for the uptime, we can choose the exponential with 120 minutes. And change the hour to the minutes. For the downtime, we choose exponential and change the mean value to 4. Then change the unit to minutes. Let's move to the frequency part. The frequency can be used. How many racks will be used in the rework area? The frequency module is in the input-output toolbar. Find it and click it. Now you will be able to add some information. We first change the frequency name to the rework queue states. Keep the frequency tab as a value. Then add the expression. Let's find the current number in queue and change the queue name to the rework process queue. Now we can see the function is the enqueue rework process queue. Click OK. Let's find the categories columns. Double click this cell, and now you will be able to see these dialogues. Click it to add some row. The first entity is for a queue set of constant 0, in which we will need 0 racks. So we set value as 0, and the category names is 0 racks. The following entities are from 1 rack, 2 racks, and so on. For now, we will only request this information for up to 4 racks. So for the next row, we change constant to range, and the value is from 0 to 10. And the name is 1 rack. The third is change constant to range. The value is from 10 to 20. And the name is 2 rack. The fourth, change it to the range, and the value is from 20 to 30. Change it to the third rack. Click it, add a new row. Change it to the range, and the value is from 30 to 40. And this is a 4 rack. When you finish it, close it. We can also add a new row to represent the cell states. So change its name to the cellular states. And keep the value, change the frequency tab to the state. Resource name to the cellular. Now we are done for this model. Let's run this simulation. Please first click the batch run, then click the run button. Now we are able to see the result. This is how result report looks like. You can compare this report with the previous report to see the difference.